users. Okay, so let's get to it. A normal database. The screen is a little bit cut. Okay, never mind. Here is a scheme of a normal database, right? So in a normal database scenario, you've got users. These users have got some roles in the database. I'm sorry, tech guys, can you a little bit squeeze the screen so that all the screen fits? Well, if you can. Okay, so these users got roles. The data, they operate on data, and the data is based on some model. And that's pretty simple. So in a normal database scenario, you've got simple injection points, right? You can inject data from the user to the application server. You can attack the admin interface, as well as the infrastructure and the database link between the server and the database. That's what we are used to. The Hadoop architecture scheme, that's magic. And that's actually what we thought after reading, screening through the documentation. And actually, when I asked some guys, hey, have you pen tested big data solutions? No, that's magic. That's a big amount of interfaces, servers, and so on. So basically, before this pen test, we couldn't find any valuable material on the internet how to pen test it. So we thought that maybe we should create it. Okay. So Hadoop is not magic. Hadoop is a standard installation. It is big. It is complex. So it contains a lot of servers, a lot of clusters, a lot of nodes in it. It contains a lot of web interfaces, as well as APIs, REST APIs, and proprietary network protocols or normal protocols running from the server to server. So this is a scheme of a standard Apache installation. There are some, the base of Hadoop, which is HDFS, the file system, the Yarn MapReduced, HBase. On the top of it, there is a bunch of application for the user and for the admin. So Uzi, Pig, Mahout, Hive, as well as Hadoop is connected to some external sources or external systems, such as authentication through LDAP or Kerberos, logging made by Splunk. So there are many injection points. This is a really simplified version. So we can attack the admin interfaces, which in most cases is Ambari and Ranger. User interfaces, which are actually the biggest user interface is Apache Hue. And in the Hue, you've got modules for other interfaces. Well, there is Splunk for the logging, out providers, so LDAP, maybe Kerberos. And of course, you can attack the LAN infrastructure, so basically scanning tests. So from the attacker perspective, it looked like this. So now, quick risk analysis on big data solutions. So we quickly answer 3 questions. Who wants to attack the big data solution, how, and what he wants to achieve? So who, from the business perspective, it's easy, right? Competitor, script kiddies, APT. What is interesting for us is who can attack it from the technical perspective. So it can be an external attacker, and he can be anonymous, or he can be an ex-employee with some knowledge about the connections between systems, the URLs for interfaces, right? And then insider. And actually, it's not strange in these ages, because many of the attacks are run by insiders from the company. So employees which got some rights in Hadoop, or an infected machine and malware on the workstation. Okay, for what? So what can be found in the big data solution? In one of the banks, we asked what data will be stored in your big data solution. And they answered, we don't know. Because a typical bank scenario is to put all transaction data, all sales data, all client data, combine it together. Then comes the big data analytic. And the big data analytic says, people who bought a dash cam are more likely to take a loan for a new car in the next month. because people have more accidents when they are pretty sure that they've got a camera and everything is recorded, right? And that is money, because if they can offer more loans, the banks got more money, right? Okay. Well, of course, data theft is a big risk in big data solution, right? For example, Target shops knew that the girl was pregnant before even she knew about it, or Facebook knows when you will get divorced even before you do. Okay, sure. So, of course, we can go for a full compromise, like code execution on big data servers, but it's not the point. So, remote code execution vulnerabilities are, of course, they are critical, and if they happen in a big data solution, it's a big risk. But it's not the point, because a simple information disclosure or data access control bypass, so privilege escalation in a big data solution, is already critical, because the big data consists of a lot of sensitive data. And of course, we've got some abuse. So a denial of service can be as critical as code execution. Okay, and if we can tamper the data, it's sure critical too. Okay, so now let's talk about how to do it. So now a quick crash course on what is Hadoop and what it is under this Sales Magic Cloud Big Data cover, because that's on the hype now. So as I mentioned, there is a base of Hadoop, which consists of HDFS and Yarn, and some application on the top of it. The more detailed information on what these interfaces are can be found on Apache websites. I will mention around 5 or 6 interfaces that were the most interesting, and they are in each of Hadoop installation. Because among the distributions of Hadoop and amongst the people who implement it, they sometimes install some of the interfaces, some not. A typical Hadoop installation consists of at least 10 to 20 interfaces, such as web interface, Uzi, Peak, Hue, and whatever. Okay. So the injection points were already mentioned. And let's go with our story with big data assessment. So we divided Hadoop interfaces into 4 groups. Actually 5. So the base is Hadoop. We've got user interfaces, admin interfaces, the interfaces which are specific for distributions, and external connections. So let's start with user interfaces. As I mentioned, the most well-known is Hue, right? In the Hue interface, you can find many other modules, such as Peak, Hive, Impala. These are modules for Hue, which offer some additional functionality. Of course, there are some other interfaces, but I've got only 40 minutes. So the first question, is Hue an internal interface? Hue allows, actually, it's the same as software for viewing the data in the database. So it allows to query the database, do some modifications, and so on. So is Hue an internal interface? It should be. But if you look on Shodan for Hue-specific HTTP headers, you find that there are a lot of, like hundreds of Hue interfaces publicly accessible from the internet. So actually, that's the first fail, because the network access to these interfaces should be really restricted. Okay, an overview of Hue may be not very interesting because that's the developing stuff, right? So let's go with attacking it. I'm going to present on Crosssite scripting. I know that Crosssite scripting weren't sexy even 10 years ago, but that's a really funny Crosssite scripting, because it will allow us to perform further attacks, which are not Crosssite scripting. Okay, so it was a simple DOM XSS. Here's the payload. This XSS is possible because, and now be careful, because it is an XSS in jQuery, in old version of jQuery, which is used by Django framework in Python, which is used by Hue. So it is, maybe it's not a vulnerability in Hue, right? But it's in external component of it. Okay, So a typical Hue attack scenario, you have to target an old Hadoop installation with this version of Hue and Django, then target the user, send him an XSS, and get access to all data that is designated for him, right? That's simple. The other things about Hue is that the default configuration really sucks. So we've got X-frame options. Oh, that's maybe not interesting. The debug interface, debug configuration in Python, in Django, that's turned on and actually can cause some real disruptions. OK, that was just an intro. And we're going to use this cross-site scripting to perform more critical vulnerabilities in the other interfaces. So let's look for the administrative interfaces. As I mentioned, there are the two most known. This is Ambari, which actually is used for provisioning and monitoring. It displays all the clusters, all the nodes, and you can view all the data there. And Apache Ranger. And Ranger is an interesting software. So it allows to introduce security into Hadoop. And from the whole bunch of Hadoop interfaces, we found the biggest amount of vulnerabilities, the biggest number of vulnerabilities were in the Apache Ranger, the software designed for security in Hadoop. OK, of course, there are some others like Nox, Zookeeper, but let's stick with two of those. OK, Ambari. That's the functionality of Ambari. So basically, it is a web interface with some RESTful APIs. This is an architecture. Maybe I'll just stick with vulnerabilities. OK. The next question, similar to Hue, is Ambari an external interface? Now, it definitely should be an external interface. But if you look it on Shodan, we've got, maybe you cannot see it, but these are maybe not hundreds, but at least tens of Ambari interfaces publicly accessible from the internet. And you can actually try to log in, brute force the password, because usually the admin username is admin. OK. So the biggest architecture problem and the bad design idea about Ambari is that it allows standard users to log into Ambari, which is an administrative interface. So a random analytic in a company or an intern, a trainee, can log into Ambari with his domain credentials, and he's got no functionality there. So he cannot view the statistics, view the logs, he cannot monitor the clusters, but he can log there. And that's the biggest problem, because inside Ambari, there can be other vulnerabilities which are possible to exploit only with an authenticated user. And now we can authenticate with a standard user account. OK. We found an interesting proxy script. So the URL is as follows. So it's proxy to some other URL. And this is an internal URL in the DMZ zone in the Hadoop cluster. And it returns some data, right? So what would you do with such a proxy script? Maybe tamper it with other values for the URL, right? Of course, we did it. So of course, it allows to download google.com content, right? But that's not interesting. Moreover, we can download logs and other files from the internal servers which are in the DMZ zone. So they are not even accessible from the local network in the company. They are in the DMZ zones in the server side. So not only we can download this data, like logs, but we can scan the whole network, map the IPs or map the network names, do a port scan, because it's possible in the server-side request forgery. So for example, this logs directory allowed to download all logs from the Yarn server, which allowed us to execute further vulnerabilities in Yarn. So we've got the server-side request forgery. This is a new CVE. Pwned. OK, so the attack scenario, that's simple, right? We have to target an old Hadoop installation with an old Ambari, hijack a standard user account, or use a Hue XSS, which I mentioned on the first slide. Then log in into Ambari, get access to the local network, and download logs and exploit other Hadoop servers. So by this simple proxy script, we pivoted into the internal network of the company, and not only the internal network, but to the DMZ zone. Okay, the next admin interface is Apache Ranger. As I mentioned, this is software made for introducing security into Hadoop. So it allows to enter some policies, which users got access to which data, which groups got access to which tables, right? This is how it looks like. Maybe it's not very visible, but this is an audit functionality with the session logs logged into Ranger. So of course there were some low-hanging fruits in Ranger. Completely no HTTP hardening, some slow HTTP DOS. We found an SQL injection, but it required administrative privileges, so maybe that's not very interesting. But as well as in Ambari, standard users can log into Ranger, but they have no permissions inside. So if they've got no permissions inside, this is how it looks for them. So the administrative interface consists of 4 tabs, and some of them are disabled for standard users. They're clickable only for administrators. Here is how it looks in HTML. Do you spot any problems? So the access control was made on the client side, in the JavaScript. And I always followed open source, and I really liked open source projects, but during the Hadoop assessment, it came to my mind that maybe open source is not a good idea, because Hadoop is developed by people around the world. Nobody checks if they have good qualifications for their work. They're just putting that on the Git repository, and that's how it works. So we've got access control to the administrative interface based in JavaScript, which we can bypass simply by copying the hash / user tab, and we are into the user administration menu. Okay, that's the mapping of the function level access control. So the red marked items were possible to bypass and shouldn't be accessible for standard users. So actually we're able to completely destroy the policies inside Hadoop, because we're able to edit users, edit policies, and view the details of policies, even delete the policies in the Hadoop database. Okay, that's the new CVE. So the scenario for this one is simple. So we have to target a null Hadoop installation, hijack a standard Hadoop account, log into Ranger, or use the Hue XSS when the administrator is logged, and perform some kind of Crosssite script, Crosssite request forgery to edit data in Hadoop. Okay. Then we use this CVE to escalate privileges, and we can do everything because we can set our user to be the administrator. This was the first one, and the second one was even funnier. So we've got an audit tab with a list of all sessions, a list of all users trying to log into Ranger. As you can see, these are login ID, the result, if it is success or a wrong password, and there is a user agent. So come on, if you've got this data, probably the first thing you try to do is try to input and cross-site scripting in the user agent, right? And it worked. So if this Ranger interface is publicly visible on the internet, or you can do this cross-site scripting in Hue, or you've got access to this interface, you can log with any user, with any password. Of course, there is a wrong attempt, but you use a cross-site scripting in the user agent. You've got the stored cross-site scripting executed only by administrators in the administrator tab. So, punch. We've got this attack scenario that we can target a null Hadoop installation with Ranger 0.4, The Ranger was previously known as XA Secure or Apache Argus. So, as I mentioned, network access or this Hue Crosssite scripting. Then we've got the admin session, and we can deploy beef or any other script to destroy the solution further. Okay, the Apache Ranger was patched. So we responsibly disclosed the vulnerability to the vendor. We did it responsibly, but for a while they did a full disclosure. How? They just put the vulnerability content on a public Jira. So if anybody would Google for XSS or access control, function level access control in Ranger, it would probably get a first result would be public Jira with these vulnerabilities. Okay, and actually it's still, after we contacted them, they deleted it, but it's still in some mailing lists archives. Okay, so let's move to the distribution-specific interfaces. Hadoop is just a software branded by Apache. It's open source, but many companies do their own distributions. So the two most well-known are Cloudera and Hortonworks. Then we've got, of course, Amazon. This is the whole graph of the biggest Hadoop distributions. So the basic distinction between them is that some of them are cloud-based, and some of them are hosted locally. And if they're cloud-based, then the problem of updating software and this kind of security is moved to the vendor, so to the owner of the cloud, something like Amazon, right? But if it's hosted locally, then the owner of the application, so for example a bank, have to cover all the updates and all the security countermeasures, right? So here comes some questions, philosophical maybe. So how long does it take to create a new distribution version? For Cloudera and for Hortonworks, the major new version comes every 1 year. The security patches may be each 1 or 2 months. But after they produce a patch, there are many updated components at that time. And later, this patch has to be implemented by the company. So deploying a new distribution at a company, of course, takes some more months. And many new components are updated at that time, right? So this is the list of HDP Hortonworks distribution components by version. So basically, what we've seen is that at least 1 or 2 months is needed to implement new version of, for example, Apache Ranger in the Hortonworks HDP. Okay, so the problem with distributions is that they've got old OS components, like programming stuff, Java, PHP, Ruby, old OS components connected to the, for example, HTTP servers, like there is an old Tomcat used by Uzi, or old Hadoop components, as I mentioned, old Hue, Ambari, or Ranger. And here comes the best question of this presentation. So I mentioned that we found some vulnerability, for example, in Ambari. We did a responsible disclosure. So if we did a full disclosure, this would be here. We did a responsible one, right? And now the distributions have to make updates, right? And it takes a few months at least for Cloudera and for Hortonworks to introduce, first, to update Ranger, second, to Cloudera to update Ranger, and then for a company which has a big data solution to update Hortonworks HDP or Cloudera software, right? What happens if this is the case with Hue? So we've got a jQuery vulnerability. If there is a full disclosure of vulnerability in jQuery, it will be in Hadoop installation for 2 years, I would say. Because the jQuery has to be patched, then the Django has to be patched, then there should be an update for Hue, then the distribution updates this version of Hue, and after that, there is a deployment of a new version. And for a bank we cooperated with, it took around 1 year to deploy a new version of Hadoop distribution. So actually, there is a philosophical question, what is a responsible disclosure? So if we contact the vendor of jQuery or Ranger, and we tell them that there is a vulnerability, and they say, OK, we patched, you can disclose. OK, we disclose, like we do it now. But probably when I talk about these vulnerabilities here, many of the Hadoop installations around the world are still vulnerable. OK, of course, we've got some other default configuration, like default passwords, SSH keys configured by default. We found default MySQL passwords in the small little interfaces, which are like helping the bigger interfaces, but there were no MySQL passwords or default MySQL passwords. Of course, the default configuration, like no network level hardening, HTTP, the HTTP security headers mostly are lacking. And as I mentioned, the Hue uses Django with the debug turned on, so you can get a lot of information from the debug in Django. OK. So let's move to the external interfaces. There are more than 25, but actually now I would say there are around 40 interfaces of Hadoop made by Apache, or small modules. So there is a lot of things to do when you pen test big data solution. Of course, not every installation's got every interface, but I would say in a typical one, we've got 10 to 20 interfaces. There are vendor or distribution-specific applications or interfaces, which is also an additional time is needed for them. We've got the monitoring tools like Ganglia or Splunk connected to the Hadoop installations, because mostly the Hadoop installations are tens of, or even hundreds of computers connected to each other. Then we've got, of course, the authentication providers, LDAP, Kerberos, maybe OAuth. Each of them should be pen tested in this kind of assessment. So we've got many apps and many targets. We started this Hadoop research around 2 years ago. I think we sent more than 10 or even 20 vulnerabilities to the Apache developers. But I think a lot more has to be done in this case. So as for a quick summary, how to protect your Hadoop environment if you are a developer or administrator of such one. Keep the network access super tight. So any administrative interface should be accessible only from the administrator IPs. Any user interface like Hue should be only accessible from the local network, not from the internet. Excessive user permissions. So you have to map business rules to permissions. Standard users like analytics, interns, or trainees should not have access to Ambari or Ranger. So the minimum rights should be introduced. Okay, for typical web vulnerabilities in the web interfaces, well, there is no other option than to pen test it. So we know how to do it, and well, you can always introduce some application-independent countermeasures, but that's a typical web assessment. For the obsolete software, well, make a list of all components. There is a tool, there is an OWASP tool for gathering all software versions and keeping the track of the CVEs connected to them. Then there are distributions-dependent vulnerabilities. So apart from pen testing the Hadoop itself, after the deployment, there should be a second pen test of simple network access or getting access to the other interfaces or to the external interfaces which were connected after the last sprint of deployment. And of course, demand security from the vendors, because if the integrator does the work for you, he should provide the proper security, right? And then we've got an external system connections. So all Kerberos, LDAP, OAuth, maybe some connectors to the, generally to the external services. So make a list of all external connections, and then you do a threat modeling to decide whether to pen test these connections or not. Okay, the current status of the Hadoop research is that people started to pen test it. 2 years ago, when we sent the first vulnerabilities to Apache, There were not so many. And actually, I'm quite happy. Today, I met a guy, and he looked at my name, and he asked, oh, you're the Hadoop guy. So, you know, actually, last, like 1 year ago or something, I was doing Hadoop pentest, and I found your materials on the internet. I like it very much. And I asked him to contribute also his knowledge to the OWASP community. So maybe we'll make an OWASP cheat sheet for pen testing Hadoop installations. So the current status for now is that we've got 2 vulnerabilities in the Hadoop core, around 3 vulnerabilities in Hive, 2 in HBase, 6 in Ambari, also 5 in Ranger, 1 in Cassandra, which is also connected to the Hadoop. Yeah, and that's actually all. And I hope that if you were pen testing, if you will be pen testing a Hadoop solution, make sure that if you found some vulnerabilities, send them to the Apache guys. Maybe we'll compose together a Hadoop or big data, OWASP big data pen testing cheat sheet. Well, why not? And this is open source software. So if you've got access to these expensive, cool, static or dynamic code scanners, reach me or leave me a card. I will reach you. Maybe it will be possible to scan the source code of these solutions because it's all open source and it's on the internet. Okay. Thank you very much. If you've got any questions, then please. Questions? Oh.
Worst case, I can reach you out via email.
Yeah, sure.
Thanks a lot.
Thanks.